It is the most hated place on Earth, a desert that is almost devoid of human life. But still, a magnificent engineering feat is being built here, which is no less than a marvel in itself. In the middle of the Atacama Desert in Chile, the construction of the world's largest telescope is underway on the top of a mountain 10,000 feet above the sea. When completed, this telescope, which is 4 times higher than the Leaning Tower of Pisa, will be able to see the distant planets of our universe 5,000 times closer than our eyes, and these images will be 15 times sharper than the Hubble Space Telescope. But building the world's largest telescope in the driest place on Earth is no less than brilliant. The Atacama Desert is the driest area in the world after Antarctica, where there are some parts where not a single drop of rain has fallen in the Atacama Desert. How will this telescope be able to go back in time and see the first galaxies and planets of the universe? How can this telescope help scientists in finding other planets like Earth? And above all, what difficulties did the scientists face during the construction of world's largest telescope in driest desert? Welcome back to another video once again. It is spread over 1,000 kilometers on the Pacific Ocean front of South America. Chile's Atacama Desert is considered the driest place in the world after Antarctica. There are such unique colors of nature here that we are probably seeing for the first time. Death Valley is a desert filled with thousands of square kilometers of salt, and there is a series of fog that is rare in the whole world. But one thing that is most essential for life, water, is not found here. The landscape of the Atacama Desert is such that it does not rain here. There are even some areas that have not seen a single drop of water. Due to all these features, the Atacama Desert presents the appearance of an alien planet, and perhaps for this reason, the European Space Agency also tested its Mars rover on it. It is 1,300 kilometers away from the capital of Chile, Santiago, and 130 kilometers away from the nearest city. This extraordinary project is under construction on this mountain, 10,000 feet above the surface, which will give humanity the opportunity to see the view of another world in space. The European Space Agency, also known as ESO, is building a huge telescope at this spot. It has been named the Very Large Telescope, or ALT for short. Although its construction is not yet complete, it will not be difficult to guess why it has been given this name. This telescope will have a huge mirror, which will not only be 49 meters in diameter, but will also be 4 times larger than the largest telescope. This mirror can collect an astonishing 10 billion times more light than the human eye, but the condition is that not a single particle of dust falls on it. To avoid this, the telescope will be covered with a huge steel dome, which weighs about 2,400 pickup trucks, almost 6,000 tons. 2 huge doors will be installed on this dome, which will remain closed during the day. This dome is so high that the Statue of Liberty can stand inside it. And if we talk about the spread, an entire football field can also be built inside it. A high-tech platform has been installed under it that enables the entire telescope to rotate 33 degrees, so that it is easy to see any part of the sky at night. It is a matter of thinking that in this remote part of the world where there is no population nearby, how could the construction team have started this complex project, especially where there were no roads, electricity, or water, and the construction from above was also on the top of a mountain? For this project, ESO first inspected many places in Europe, but in the end, they had to choose this location in South America. ESO is a government organization of Europe with members from 16 countries. ESO's project head says that there are many reasons behind selecting this place for the telescope. The first is that they wanted a place for the telescope where there is no city in the distance. You must have noticed that even at night, there is often light above the cities. And if there is a cloud above, they would also be clearly visible. This light is much brighter than the light of a star thousands of years away, which can spoil the image generated by the telescope. But many such locations exist in the mountains in Europe itself. So why was this location in South America chosen? It is not enough to protect the object from the weather alone. Having a clear sky is also very important. Europe has a mostly tropical climate, which is why there are often clouds here. But the Atacama Desert is one of the driest in the world. So out of 365 days of the year, there are no clouds, which is very important for seeing distant galaxies. In 2003, ESO's team tested different places and finally found the location of the Atacama Desert to be the best. Everest, a 3,000-meter-high mountain called Cerro Amazon. But the problem was that, like other mountains, it was quite a sharp mountain, meaning that any kind of construction on it would not be possible in this condition. Therefore, it was very important to cut the top of this mountain and level an area as large as 7 football fields. Imagine a 3,000-meter, 49-pointed mountain and build a huge field on top of it. This work was very difficult and dangerous to do with the help of excavators. Therefore, in 2014, the construction team got the help of explosives. Holes were made at the top of the mountain. Explosives were inserted and torn off using a remote controller. In this process, the top of the mountain was cleaned up, which contained 47 million cubic meters of soil. This was enough soil to fill 1,911 Olympic-sized swimming pools. After removing the soil and stones, the top was leveled and a path was also made to reach the top. But this was just the beginning. A flat field as wide as 7 football fields was created on the top of the mountain. But at the same time, a huge problem emerged. A problem that stalled the construction of the tower for the next 5 years. The engineering team noticed that sinkholes were forming in places on the top of the mountain. They would refill it, but after a while, many spots would automatically sink in. This was the biggest problem standing in the way of laying the foundation of the tower. Originally, the top of the mountain was blown up by pouring ash, which had caused a lot of damage to the core of the mountain. Cracks appeared in the rocks, and soil started sinking in from place to place. Every few months, the rocks would move, and then new sinkholes would form. To deal with this problem, engineers drilled several holes in the field and artificially stabilized the ground with the help of vibrators, so that as many holes as needed could be made at once. Finally, the vibratory method worked, and the holes were filled, and the top of the mountain was leveled again. It took the next 5 years to complete this entire process. Now the next step was to build ELT foundation. This was not an ordinary foundation. This part of the Atacama Desert is a seismically active region where the earthquakes are very common. To protect the expensive parts of the telescope from earthquake, a foundation was kept separate from the upper dome. Several hydraulic shock absorbers have been installed between the foundation and the dome, which do not allow the shocks of the earthquake to reach the metal dome and the telescope mirror inside it. The foundation work was completed in the 2003, and now it was the turn of the telescope's amazing dome. The steel structure of the dome was built in separate sections at the bottom of the mountain in base camps. Then, remote-controlled trucks were used to transport these sections up the mountain, one by one, to the top of the mountain. After reaching the top, cranes joined these formidable structures together. The network of roads to reach this part of the Atacama Desert was largely pre-built because there is another telescope of ESO, 20 kilometers away from the other side, which is called the Very Large Telescope, or VLT. The mirror of the telescope, which is 100 meters wide, is behind the construction of the world's largest telescope. Currently, a structure is being built inside the dome to control this large mirror, and you can guess how big it is from the worker standing on top of the frame. This 39-meter mirror is being made by combining a total of 800 small ones, whose job is to combine any light coming from space and deliver it to the secondary mirror, M2. From the M2, this light will go to the M3 and then to the M4. The M4 will make the image sharper, and for this purpose, powerful laser beams on the dome will be used. These lasers are usually set at a wavelength that excites sodium atoms in the 90-kilometer sky, causing them to glow and create an artificial star. The telescope uses this artificial star as a reference point to determine in real time how the atmosphere is scattering or blurring the light. When the irregularities in the atmosphere are detected, the blurring in the telescope's image is easily removed. This whole process is called adaptive optics. After removing the blurring of the image from M4, the lens goes to M5, and here the image is corrected and sent for processing. So much has been said about the wonderful working of the telescope. The biggest question here is, what will we finally get through ELT? ELT will be the only telescope that will be able to take direct photos of exoplanets outside our solar system, those planets that are far away from human life. Currently, these exoplanets can only be seen by other telescopes indirectly. Only when they pass in front of their star, we clearly see their shadows. Through direct photography, we can know what the atmosphere is like on these planets, and the atmosphere will tell us whether there is water or not. Is there carbon dioxide or oxygen, or is there any kind of creature that is creating pollution like on Earth? Because of the large mirror of the telescope, it will be able to collect a lot of data, and through it we can also see into the early days of the universe. If you don't know, Let me tell you that the light has a fixed speed and it cannot travel faster than that. With the help of this, we can easily see into the past of the universe. Its simple example is, the first ray of our sun rises every day. We are actually seeing the past because the sunlight takes about 8 minutes to reach the world. The Hubble Space Telescope can also look back 1,340 billion years in the universe, meaning its mirror also captures the dim light that was released in the universe 1,340 billion years ago and has reached Hubble today. Unlike the 39-meter-wide mirror of the ELT is capable of looking back 10 million years, even more than the Hubble telescope. According to scientists, the Big Bang that created our universe occurred 1,380 million years ago. This means that the ELT can also see the universe 30 million years after its birth. It is also important to know that the ELT is quite large, but it will only be the largest telescopes based on mirrors, while a radio telescope has a very large dish, like the Golden Eye. Instead of mirrors, these telescopes look at the past through radio waves, and then through computer processes their images are made. But in direct view, ELT will be the largest telescope in the world. Let's talk about its cost. The cost of this is estimated at $160 billion. This is almost the same cost as the construction of the world's tallest building, Burj Khalifa. According to experts, the construction of the telescope will be completed in 2029. After being fully prepared, it may be able to answer the biggest question: are we really alone in this universe, or life has settled on some other planets? I hope you will also watch and support this video. Thank you very much for your comments. See you in the next video.